Welcome! In this 7th section, we'll be looking at a very interesting topic that is an Internet of Things. So we'll be streaming processing of sensors data, we'll be inserting data to Apache HBase from Spark Streaming Job. Also, we'll be calculating statistics from our sensors data. And this is a first video in this section, and in this video we'll be storing low granularity structured sensor data in Apache HBase database. We'll create a streaming job that loads sensors data. We'll be saving that sensors data to Apache HBase for further processing and analytical purpose. So before we start, we need to start an instance of the Apache HBase. So let's start it. We need to type an HBase master start, and it will create and start new master node on our local machine. After a while, our HBase will start. So we are given a sensor data.csv file. It has a multiple records, as you can see, and also multiple rows. We have a case class sensor that is a representation of those rows. So it has resource identifier, this is a string, then date that is also presented as a string, and time that is a string. Next we have some kind of specific sensor data. We have HZID, display, floor, set ppm, PSC and CHL ppm. All values are double and are a specific sensor data that could be used for analytical purpose. Next we have a sensor companion object that is parsing that string that will be fetched from CSV file. So we are taking a line, we are splitting using comma, and we are creating new sensor case class, taking all elements from that parsed string. And this is an array of strings. So if you want that is a double, we can call a toDouble and we'll cast that string to the double. So let's look at the streaming job that is able to insert data from streaming input to the HBase table. So our streaming job needs to have a main method when we are creating new HBase connector and calling a connect method. So let's look at the HBase connector. It is a simple class. We are firstly creating a new HBase configuration. We are loading HBase site file. This is an XML configuration file that consists of properties where HBase is. We started HBase on the local host, so we are specifying localhost here, and port is default 2181. It will load that configuration, add it to the path of config, check if the HBase database is available. If it's not, it will throw exception and we will know instantly that something is not going okay. And we are returning new HBase connector class with configuration underneath. We have our HBase set, but we also need to set an output table here. So we are setting it to table name, and table name will be sensors. We will need to create such table in the HBase. We will see it in a moment. Next, we are creating new job configuration with that HBase conf. This is a Hadoop configuration, HDFS actually, because HBase is using HDFS, and we are passing this class. Having job configuration created, we need to set the output format to table output format. This is from Hadoop package. We need to set an output table once again, but at the higher level. This is job config level. We are creating new Spark configuration for our application and we'll be working on local machine. So we are passing master local. This will be a streaming application. So next we are creating new streaming context, passing Spark config here and seconds of Windows. And Spark streaming context has a very useful method for debugging and also for production use, because not always stream of data will be from the Kafka or some queue. In this example, we are treating file sensorsdata.csv as the stream, because file is also a stream. We can append the values to the tail of that file and will be then new value in our stream. Also, if new file will appear here, it will be treated as a stream loaded to our processing and processed further. So when we load our sensor data in that folder sensor, we need to parse it, we know that method already, and at this time we will have our sensor. We are printing some elements from sensor dstream, and next actual saving to Apache HBase is happening. So for each RDD inside of the dstream, we are calling filter. So we are calling filter using sensors.pse that is lower than 5.0. We are filtering out all those values and it will be an alert RDD. It means that something is going not okay with our sensor and we need to report it. We are taking one element for debugging purpose and we are printing it. Next, we are saving all data using that outer RDD. So first you need to convert it to put, and put is a specific HBase operation that will be used. So we have a sensor data, and first we need to create row composite key. So we are creating key for our data, will be date and time. So this is a specific time, and also resource ID. So this will consist from 3 fields, our key from data. So if you want to load that specific record, we need to use resource ID and data and time. Next, we are creating new put operation for that row key. So we are passing row key and transforming it to bytes because interface with Hive is that everything needs to be presented as byte array. Next, we have our column families and columns. So we have column family data that will have multiple columns. That column family data needs to be also presented as a bytes here. Then we have column hazed bytes, these bytes, and so on. So every column needs to be presented as the bytes, and we are inserting data also as bytes here. At the end, we are creating immutable bytes retable. That is a type from Hadoop. We are passing our row key and put operation. After converting it to put, we can use a save as Hadoop dataset, and using job configuration, the Spark will know that it should use HBase because we created a configuration that is pointing to HBase database. So it will use HBase connection string, that connector that we created, and insert that data to HBase. But as we remember, we also have an RD. So for each record that sensor.psi is lower than 5, we want to convert it to put alert. We want to create an alert. So we are creating row composite key in the same way, exactly the same way as for the previous operation. We are creating new put, but we have new column family. So column family will be alert this time. And in alert column family, we will have only one column inside, and it will be column PSI bytes. We are converting PSI to bytes, and we are creating new immutable bytes readable. At the end, we are calling exactly the same method as previously, save as Hadoop dataset, and that method will figure out underneath how to save it to HBase. At the end, we are starting our processing and waiting for termination of our processing.